Good afternoon, good evening, good morning, good day to all of you joining in. We will have more joining in, I'm sure, during the hour. And like I mentioned, we are recording this meeting. The primary purpose for today is for Tori to report back to everyone the outcome from the criteria workshop that you all participated in, to tell you how the CLD is handling all of the information that you shared, all of your wonderful output in those working groups together, and how we're now proceeding moving forward. And so, Tori, the floor is yours.
All right, thanks. I am going to stop my video so you don't have to look at me, and then share my screen so you can look at what I want you to see. All right, is that up?
That is. Once you go full screen, should be good.
Awesome. Okay, so thanks very much for joining us. I really appreciate your turning out. I think I recognized everyone's name that I saw in the participants list, so it's kind of a big room full of friends. And this is not meant to be formal. It's really just a chance to report back to you, to show you that your feedback that you kindly gave us didn't disappear down a black hole. And it's also an opportunity to try and encourage you to take the next steps with us as we move along in this process. So here's what I thought we would try to cover today. I want to briefly recap the workshop, since it's been, in one case, almost half a year, I think, since we did this. Hard to believe that that's happened and that time has passed. I want to tell you what your feedback was. I know that you're all aware of the feedback that came from your individual groups, but I want to tell you what the feedback was collectively from the workshop as we synthesized it, and what we've done with it, how we resolved the things that you felt needed resolving, and a few things that are still pending, and then what our next steps are, and opportunities that we hope you'll join us with as we continue along the way. So just to begin, I want to remind you about the motivation for this. When the National Academies published their consensus study report on astrobiology strategy, one of the recommendations was that NASA should support the community in developing a comprehensive framework for assessment of biosignatures, which they said should include the potential for abiosignatures, false positives, and false negatives, the purpose being to guide testing of in situ and remote biosignatures. And so the workshop that you all participated in really was the commencement of an effort to do exactly that, to support the community in developing that framework. And framework we conceive in two ways. The first is as a conceptual framework for evaluating biosignatures, and really there the goal is to work together as a community with a diverse set of perspectives and opinions to reach a consensus on a standard set of criteria for assessing the utility of a diverse range of biosignatures. And standard really means that we can apply the same set of criteria universally across features that may differ very much in their characteristics. And that's where we really asked the workshop to contribute. So we asked you to think of things at this conceptual and truthfully quite abstract level. And I know that that created a challenge of maybe not having all of the context that you might want. But we felt that it was important because the notion of criteria should stand alone. And we wanted you to think about it in those abstract terms. But when I report back to you today about what we've done, I want to present it back in functional terms, because for us, the next step is to use the community consensus criteria as the organizing basis for an actual functional system that's designed to capture knowledge and operate on that knowledge relating to biosignature measurements. And so we asked you to think in conceptual terms. We're going to report back in the functional terms. And this goes to Joey's question about workshop participation. I thought you might all be interested to see this. When you registered for the workshop, we asked you to provide a little bit of demographic information. And so here's how it broke down. We did have, as Graham said, 52 participants ultimately that were distributed across 2 workshops that were almost identical. Not quite identical, because again, we asked you to fill out an exit survey from the first workshop, and we used that information and that feedback to tinker and tweak a little bit the way that we presented the second workshop. But the goals effectively were identical, and the way that we broke people out into groups were identical. I was really pleased with the mix that we had among mid and late career folks, postdoc and early career folks, and students. It broke down very well. I'm particularly excited about the idea that we have a lot of participation from the younger community in this, because I think that younger community is really the ones who are going to carry the life detection endeavor forward. And in terms of a disciplinary breakdown, We also had a nice mix between biology, chemistry, geology, and a bit of astronomy as well thrown in there. And importantly to me anyway, about 30% of you indicated that you were involved in some way or another in technology development. And that's important because this endeavor really does need to be a meeting of the minds between scientists and technologists. So I felt that we achieved the objective of getting a real diversity of perspectives to bring to bear on this question of developing criteria for biosignatures. And so as you'll recall, really the meat of how we pursued this was to break the participants out into what were ultimately 8 breakout groups that were led independently. So we purposely asked some of you to step up and lead these breakout groups, some of you who weren't part of CLD, weren't part of the initial conception of the draft criteria that we put in front of you, and asked you in the big picture sense to consider, first of all, whether the framework that we used for developing our draft criteria, which was related to assessing the potential for false positive and false negative, as the National Academy suggested, was an appropriate framework and a useful framework for biosignature evaluation. And then within that framework were the draft criteria that we presented you with complete, meaning did they provide you a way of saying everything that needed to be said about the potential for false positive and false negative results when seeking a given biosignature? Were they universal? Meaning, could you apply them equivalently across all of the diverse biosignatures that you came to bear with? And a lot of the groups actually did go through this exercise of bringing together or bringing to bear diverse biosignatures and seeing if you could make them fit into the scheme that we provided. And finally, were they disjoint, meaning were they non-overlapping so that we could avoid double counting of some factors in the way that we pursued these things. And so we set you to work in these. We gave you a week, which wasn't very much time, I realize, and asked you to come back and provide your feedback. So the criteria that we put in front of you, just as a reminder, in case these aren't etched into your brain as they are into mine, were biological prevalence, abiotic prevalence, the strength of a biological signal, and the strength of an abiotic signal. And the idea is that collectively, these 4 features would determine the potential for false positive and false negative. And that's what we asked you to consider. So the feedback that we received from you was received in several forms. All of you gave breakout group presentations in the plenaries at the end. So we captured those presentations. We captured the notes that the rapporteurs kindly provided, also the notes that the CLD members who sat in on your breakout groups provided. And we put them in front of 4 independent groups of CLD members and asked them to independently synthesize and have a look at what things rose to the top, what things were repeatedly called for by different groups. And I think first and foremost, we found that none of you called for an overturn of the false positive, false negative framework. That was generally seen as a useful way to move forward. And that was positive and encouraging for us, given that it's consistent with what the National Academies recommended. Then we found a variety of things that we considered potentially structural issues. So things that had the potential to change the way that we viewed or presented the criteria to the outside world. And really the things that bubbled to the top as items that came up multiple times from multiple groups were, first of all, contamination as a potential contributor to false positive. And that wasn't represented in the initial list that we gave you. So that represents a possible new criteria that a couple of groups called for. Environment was probably the most raised issue, although in the way that we articulated the criteria for you, we referenced them to environmental context and made it clear that those are environment-dependent interpretations. You really called out the need for us to better clarify what is meant by environment, and also in some way or another to associate uncertainty with a knowledge of environmental context that may be incomplete. And finally, there was a call for unpacking of the 4 draft criteria, by which I mean providing a little bit of greater granularity to show users what is meant by these criteria, what comprises them, how do you relate them to previous criteria that had been expressed in the literature. And finally, I think there was a notion that we needed to be more precise in the terminology that we use to describe the criteria and also the other associated information. and to provide context. So I realized that in the presentation that Nikki gave to all of you, for example, in the beginning, we tried to provide a great deal of context, and even still, it was important, perhaps because of the abstractness of the task, to have even more context provided than what we did. And so I'll try to walk through how we did these things. So I want to briefly say that the next steps, as I mentioned, we asked you to consider this as sort of a conceptual and abstract exercise, but the way that we're going to use it in our next steps is the organizing basis for a system called the Life Detection Forum System. So this is meant as an online repository for knowledge about biosignatures and also about various technologies that can be used to make measurements associated with those biosignatures. And we want to use the criteria as an organizing scheme that will support risk assessment and science traceability associated with missions that seek these biosignatures as evidence for life. And this is really important. So the system is modular in the following sense. We track information about biosignatures and about associated measurement capabilities in a separate but linked fashion. And that becomes important in understanding how we've used your feedback. We felt that it was important to do this because you may have a biosignature that is very promising, that could serve as excellent evidence of life in many ways, for which the measurement technology is as yet immature. But the fact that the measurement technology is immature doesn't make the biosignature any less valuable. And so we felt that what we should do is track in parallel our knowledge and understanding of biosignatures and our capabilities for measurements, so that at any given point in time, we can compare between the two and say what is possible now. But at the same time, look at the gaps in technology development or the gaps in knowledge and say, if only we could make an advancement here, we really would stand to advance our readiness to search for life. And so it's important to bear in mind as we go through this, that these are separate things and that the information in the knowledge base, which is what I'll spend most of my time discussing today, the life detection knowledge base, is to the greatest extent possible independent of implementation and measurement methodology. But it recognizes that almost everything we can say about biosignatures is necessarily couched in environment-dependent terms. And so keeping in mind the way that we've tried to parse and distribute that information is important as we walk through this. So to zoom in on the knowledge base a little bit, because this is the way that we've actually tried to reflect the feedback that you've given us. This is a system that is designed to capture the existing state of knowledge about biosignatures, so sort of a diffuse set of astrobiology knowledge as represented in the literature, and organize it in a very systematic way. And it's organized in the following way. We subdivide the knowledge by biosignature, so it's specific to a given biosignature, for example, an enantiomeric excess in amino acids. And that biosignature is then described, its utility or its risk as utilized in a mission is described by the criterion that we've put in front of you. So here I've just put it as criterion 1 through criterion N. I think that what you told us is the set of criteria that we were using, the 4 basic criteria, were for the most part complete. And so you can think of criterion 1 through N as being the biological and abiotic prevalence, the biological and abiotic signal strength. And really, those are ways of collectively assessing the utility or risk of seeking a given biosignature. A given biosignature, then we try to define the interpretation of a criterion in terms of arguments. So a user can go into the system and argue that the prevalence, for example, of an enantiomeric excess in amino acids will be high across the board. So I don't know if you can see my cursor, but this criterion, suppose this is biological prevalence, then can be supported by arguments for high prevalence, arguments for low prevalence, and arguments are in turn supported by evidence. And evidence in this case comes in the form of published works. So really, if you look at it from the bottom up, this is a structure for organizing the existing state of knowledge as represented in the published literature and showing how it comes to bear on assessing the utility or the risk of seeking a given biosignature. The other aspect of having an online system like this is that we can provide in the course or in parallel with this system contextual and training materials. And so a lot of the calls for precision in terminology, inclusion of context, structure in which to consider the criteria that we've put in front of you can be built into the system. And we've taken to heart what you asked us for. We formed a terminology group that went through piece by piece our different criteria, but also all of the associated terms, and tried hard to come up with definitions for those that are precise, to come up with use examples, to phrase them in the form of questions and so forth. And so here we have a structure, but also a chance to provide context and training for how to use that structure. And an important distinction to make is that the top part of the structure, the organization into biosignatures and criteria, is sort of hard-coded into the system. That's the way that the organizational scheme is designed. And it's designed on that basis. It's the reason that we pressed you to try to help us finalize the criteria, because that's the part of the system, the organization scheme, that's hard-coded. The bottom part, though, the way that we argue for or against a given criteria, that it's high or low, and the way that we support those arguments with evidence, is all user contributed. And that's the basic idea behind this system, is that we're crowdsourcing the knowledge. We're allowing the entire community to weigh in on the suitability and the usefulness of given biosignatures. And I want to talk briefly now about that user contributed aspect, specifically in the form of arguments and evidence. So user-defined arguments really, really lie at the heart of the way that we've built this life detection knowledge base. And they provide a lot of the basis for addressing the feedback that we received from you in the course of the workshops. And so an argument in the specific way it's used in the knowledge base is specific to a biosignature and to a given criterion within that biosignature. So in the example that I used, it might be the prevalence of an antiomeric excess in amino acids. That part is fixed. What the user then provides is a specific argument to support high prevalence. So in the case that I've given here, an argument is a statement that supports or contradicts a given thesis. So the argument that I'm trying to support may be that biological prevalence of an antiomeric excess in amino acids is high. The way that I would term a specific argument might be that functional polymers must be homochiral, implying that the prevalence of an antiomeric excess is high. I need to support that in the system by providing evidence, and the evidence in this case is a fact or information as represented in the published literature that helps to establish the validity of the argument that I've just made. In this particular case, it points to a piece of literature that says that all attempts to evolve ribozymes with mixed chirality have failed, again implying that functionality in polymers requires homochirality. So this is really the place that the user can get in, use their understanding and specific knowledge of biosignatures, and make particular and very specific arguments as to prevalence and signal strength. So I want to walk through now the three big items that we perceived you all to have called for. Unpacking the criteria, meaning a call for greater granularity in the way that criteria are defined, the accounting for environment, and the contamination issue. So first of all, unpacking the criteria. Your feedback for us really underscored the importance of providing granularity within the four criteria. I think there was a sense that they were more or less complete, but that they were a little diffuse in the way they captured the knowledge, that you looked for more granularity. And in particular, you felt that it was useful for us to try to demonstrate the relationship between the four criteria we presented you with and criteria that had been previously articulated in the literature. So the examples that we provided you with, things that we plucked from the literature and considered in formulating our four criteria, were universality, the extent to which the biosignature is produced by all life, reliability, so that's the probability that a positive result accurately reflects the presence of life. Congruence, meaning is the target environment suitable for organisms express that the feature, or rather, would you expect biology to express that feature in a specific environmental context? Patchiness, the acknowledgement that some features are heterogeneous in space or in time. Survivability, a recognition that features once produced by biology are subject to degradation that is dependent on the specifics of the environment. And finally, range. Range is a statement about the extent to which looking for a given biosignature or making a given measurement can be informative even when you don't get a positive result for life. So the way that we've tried to handle this is first of all by the provision of contextual materials within the knowledge-based system. So these would be training materials, they'd be background materials that we provide within the system to users as a guide to what information belongs where. So when you come to the system as an expert in a given biosignature, you understand what needs to be said about that biosignature to express its pros and cons. It may not be as clear how to sort that information into the standard framework that's represented in the system. And so the notion here is to represent our 4 criteria in sort of a dendritic or a diagrammatic way that allows perhaps more familiar terms to be mapped into the terms that are used in the system. So universality, we felt, as expressed, for example, in the Ladder of Life Detection paper, really is equivalent to biological prevalence as we've expressed it in this system. Reliability, which recall we defined as, or had been previously defined in the Ladder of Life Detection paper, as the probability that a positive result accurately reflects the presence of life, really is the superset of what we defined as abiotic prevalence and abiotic signal strength. So together, those 2 things determine how likely it is that when you see a given feature pop up, that it's actually the representative of life and not of abiotic processes. Congruence, as we defined it, so does this feature make sense to be produced by a biology in a given environment, is really just an environment-specific assessment of prevalence in the broader sense. And then the terms patchiness, survivability, and production, which we introduced as a new term, all are contributors to the signal strength criteria. And finally, range is something that we debated a lot internally in the group. And where we've arrived is that the aspects of range, which is sort of a catch-all utility parameter, the aspects of range that specifically influence the probability of false positive and false negative remain to be precisely delineated. And because they remain to be precisely delineated, we've yet to code them into the structure of the life detection knowledge base. So in walking through these things, I don't expect to resolve all of the questions that are in your mind. I'm just trying to indicate the way in which we are presenting to you and to future users of the system an equivalence between existing terms in the literature and terms that are used in this system. So the second way that we demonstrate this relatedness is that when you as a user enter a new argument, you're able to define an argument type, a predefined or select a predefined argument type that relates that shows how your argument specifically relates to the criteria in question. So when you are entering a prevalence argument, for example, you can select that you're specifically looking at congruence, you're making an environment-specific assessment of prevalence, or a general argument about prevalence, meaning that this argument is independent of environment and more intrinsic to the feature. Likewise, when you make a signal strength argument, if you choose, you can say that this is something that's very specific to the biological production of that feature and the way that environment influences that production, or rather, it's specific to how that feature survives in its environmental context, or its patchiness, or general. And when the system presents users with a set of arguments that have been entered, so a person who goes in and browses the system to look at what's been said about a given biosignature, the arguments are by default displayed and sorted by user-defined argument type. And so both of these are really just meant as guides to provide a little bit of extra granularity to help people understand what is meant by the 4 basic criteria and how they map to terms that may be a little bit more familiar and understandable. So I want to talk briefly now about environmental context and uncertainty. This was by far, I think, the biggest thing raised by the breakout groups and the most challenging issue that we faced in trying to understand how to capture your feedback and implement it in the context of this system. And each of the groups, I think, had something interesting to say about environment and a different perspective on environment. But I wanted to offer here some language that came from the group that Jada Arney led, because I think it really nicely captures and sums up the problem. And they said, first of all, that the scale of the environment is variable. Environment can mean a specific locality. It can be a global or a planetary scale. It can imply temporal scales. It can even imply ensembles of localities of planets. And so there's a really broad range of scales. the context for environment that may come to bear on interpretation of our different criteria is the full set of physical, chemical, and other properties within the environments that are relevant to a given biosignature. So in my mind, that really encompasses the challenge. It's the full set of physical, chemical properties that matter. So this may be conditions, it may be processes, it may be something as specific as temperature or radiation, it may be something as generic as the way the planet provides energy to its system, or a place like subsurface or atmosphere, or so there's a great diversity of things, and spanning that diversity and representing in the criteria was really the biggest challenge. And then finally, there was a statement that I think is a very, very important one, and that is, the more complete the knowledge of the environmental context, the more confident we can be in inferences based on the criteria. And by contrast, the less we understand about that environment, the greater the uncertainty. This is really important because if we want to make an assessment of the standing state of knowledge about biosignatures and understand the risks associated with making that measurement in the context of a mission, we really, really need to capture the uncertainty inherent in doing so. So if you have something that's very heavily dependent on environmental context, that is poorly defined going into the mission, you inherently have a lot of uncertainty in the ability to interpret your results, or at least in the ability to understand how valuable that measurement is going to be when you decide to include it in your mission. On the other hand, if you have an aspect of a biosignature that really, really is intrinsic to that biosignature and independent of environmental context, you can be fairly confident that even if you don't understand the target environment very well, you do understand the utility of that biosignature. And so as a complete set, this notion of capturing different scales, of capturing a great diversity of parameters that matter, and of using those parameters to say something about the uncertainty of risk associated with using a given biosignature, really is what we would like to package up in the way that we represent environmental context within this system. That was a challenging thing for us to do. Here's the way that we tried to approach it. So as I mentioned before, user-contributed arguments, user-defined arguments and evidence within the system really provide the flexibility that we need to try to reflect environmental context and other things that matter. So we've done this in two ways. The first is that when you as a user enter an argument into the system, I think that the prevalence of an antiumeric excess is high. You can select a target environment from a predefined list. So by target environment, we mean environments that may be likely to be sought in a search for evidence of life beyond Earth. So a target environment might be, for example, the subsurface of Enceladus or the atmosphere of an exoplanet. And when you make a selection, you're in essence saying, I think that the argument I'm making is specifically relevant to this criterion, for example, biological prevalence, in this place, for example, the subsurface of this ocean world. So the primary role here is really in selecting these things, you're providing a basis for users to search or filter. So I want to understand something about an antiumeric excess, but really I'm interested in its application to ocean worlds. You as a user can go in and see where contributors have specifically made an argument that is relevant to ocean worlds. And it serves a role in search and in filtering. But really the more flexible aspect of user-contributed arguments comes into play in the way that you as a user articulate and make a specific argument. So the wording of the argument and the way you choose to involve environment in that is completely up to you as a user. You can invoke a specific environmental condition, a process, a locality, any of the diverse range of things that you feel matters in the interpretation of a given criterion. So I, as a user, might say, for example, the signal of bulk and antiumeric excess diminishes, so here we're talking about the signal strength criterion, diminishes as energy flux to biology diminishes. And I've put energy flux in red because that's the specific environmental condition or process that I think matters in articulating an argument about this criterion. So we're hopeful that through the combination of these two things, we've provided the flexibility to both express where a given argument is applicable, but also to help choose among the really diverse array of features that may come to bear in interpreting a given criterion. And I think what's powerful here is that by articulating these arguments and expressing them in environment-specific terms, you help to build in a sense of certainty or uncertainty. So when you make an argument that is largely independent of environment, you again are arguing that you can pursue that measurement with a fair degree of certainty in terms of its risk and value. By contrast, if I make an argument that this parameter is very heavily dependent on energy flux, and I'm going to deploy it in an environment where I understand almost nothing about energy flux, I've introduced a high degree of uncertainty. And so this is really the place where you as users can help to reflect uncertainty in the system. And that's critical bit of information in formulating and building mission approaches. So pulling all of this together, as a user of the system, when you go to put an argument into the system, you would see an entry field. So for example, as you see on the left here, you're prompted to enter an argument that allows you to select from a list of environments that represent filters on information that users see. You can select an argument type that is specific to the criterion you're looking at, whether prevalence or signal strength. And then you can specifically articulate an argument in your own words as to how environment, as to how productivity, survivability, patchiness, all come to bear in interpreting that criterion for that biosignature. And the hope is that this provides the flexibility that you need to say what's necessary to say about how a given criterion should be interpreted. So finally, the question of contamination, which was brought up by several groups. This was also a bit of a challenge for us because unquestionably, contamination is a potential source of false positive results. And in this sense, it belongs in a false positive, false minus scheme, should be captured. On the other hand, recall that the way we've set this system up is that the knowledge base itself is meant to be all about information that is specific to biosignatures and independent of implementation. And contamination, the potential for contamination, is mostly, but not completely, an implementation issue, meaning you can choose the degree to which you choose to decontaminate your spacecraft, the means by which you decontaminate your spacecraft. That's implementation. But when I say mostly, there is one aspect of a feature that does determine its potential to contribute to contamination and therefore to false positive results. And so the probable resolution with an implementation pending is a new criterion that we've called distinctiveness. So the idea here is that distinctiveness is defined relative to terrestrial life. If something is fully distinct from terrestrial life, that is, we see it as a feature of a biological system, but one that is not represented at all in terrestrial biology, then it carries little or no potential for terrestrial contamination. At the other end of the spectrum, if something is a universal biosignature, it is a sign of every form of life, no matter what form that life takes, then inherently seeking that feature offers the potential for contamination. And so we have sought to define this new criterion of distinctiveness, and I'd be interested for all your feedback here. It's pending because we've yet to decide where and how to place it within the scheme that we've defined for the system. So finally, what are the next steps? And I really hope that you all will follow us along in these next steps and become involved in what we do next, because the power of a system like the one I've described really derives from its usership. The more of you contribute to the system, the more you put your knowledge and represent your knowledge within that system, the greater an aid it becomes to thinking about what biosignatures to pursue in a search for evidence of life beyond Earth. So first is follow-on activities to the workshop that you all participated in. The next thing I think you can look forward to or look toward is a workshop report that we'll post to the Enfold website, and we've established a page specific to the Life Detection Forum on that website. We aim to do that by spring. And really what the report, excuse me, what the report will comprise is the information that we presented all of you with in the workshop. So the basic criteria, the reasons for having chosen those, the criteria for criteria, a description of how the workshop was pursued, the methodology that we used, the contributions that all of you made, and then a summary of the feedback and its implementation. That you can look for by spring. We will then proceed to generate a draft paper for an astrobiology special collection. We've already spoken with the astrobiology journal editors about this, and there's a lot of interest. in seeing this represented in a special collection of papers. So that paper, again, will represent not just the criteria, but also the workshop that was used to collect community feedback. And that's something that we hope to involve many of you in as we begin to draft it. The next step for us is to build this information into the life detection knowledge base, as I've just described. And as many of you know, we're hosting a workshop on the knowledge base and the associated measurement technology forum next week in this same time slot. I know that many of you are registered for that workshop. I really appreciate that you are. I'll mention that at the present time, we have, I think, more than 140 people registered for that. So there's a lot of interest in taking these next steps. And the ability to have done so derives entirely from the feedback that you provided us in the workshop that you all participated in. So what will happen there in the session next Tuesday, the plenary session, is an overview of the knowledge base and the measurement technology forum platforms in the form of a plenary presentation. We'll then break into working groups, but working groups that are different from what you all participated in. So whereas your working groups were closed-ended, you had a week to parse through the information that we'd given you and provide feedback. The intent here is instead to make them a little bit open-ended. So we envision that they'll meet regularly throughout the spring to take the knowledge that you have about biosignatures and implement that knowledge into the knowledge base platform. So to work as groups to parse and take the content that you know and place it in the organizing scheme represented by the knowledge base workshop. That serves two purposes. One, it's to help build the content within the knowledge base, but second, it provides use case examples for whether or not the scheme that we've come up with really serves the purpose. In all of the cases, in all of the biosignatures that we can try to include content, does the system work? Does it allow you to say everything that needs to be said? And that process we envision also ultimately resulting in a series of papers for this same special collection in astrobiology. So I really hope that all of you will join us for that activity. And then finally, and I should note that this is proposed, so the ability to do this is pending support for it. Over the coming years, we would look to take the knowledge that is built into the knowledge base and use it as the basis for risk assessment and science traceability. So if you want to pursue a given measurement in searching for life, what's the risk inherent in doing so? The risk of false positive, the risk in false negative. And how do you trace a specific set of measurement requirements back to the objective of seeking life? So the idea would be to use the knowledge base content, build in modules that help users to do this, and training materials that demonstrate how to do so, that we would then present in workshop formats very similar to this. So these are the next steps. I hope that you'll join us along the way because all of you really have been in on the very ground floor of this effort. So I want to thank you very much again for your support of this project. The time that you put in, the feedback that we received has really been essential to our ability to make progress on this. Please stay involved. And I want to stop now, pause for any questions, and finally direct you to a page that we've established on the Enfold website that hosts resources for the Life Detection Forum project and the specific workshops that you're participating in. So let me stop sharing, turn my camera back on, and see if there are any questions.
I had a question. Hello.
Yeah.
I will reappear after my pizza lunch. I was curious kind of about the layering of the environments that you've put. They appear predefined, and obviously it can be as specific and granular as one could possibly imagine. So I'm wondering if that's an element that can be user defined, or if it's kind of going to be ocean worlds, Enceladus, et cetera. And that's sort of the set context. I also noticed, again, that was probably just a subset of what you have, but there was no kind of historical component like an ancient Mars or, one of these places at a different time in the past. Curious about that.
Yeah, as I mentioned, I mean, you can't imagine how many meetings we had to wrestle back and forth with what was the right way to represent this in the system. And ultimately, the reason for deciding on a sort of two-layered approach for doing this, one with predefined target environments and the other with completely user-defined conditions, was to try to meet both needs at the same time. So the first need, meaning, for example, I'm a Mars scientist, exoplanets and ocean worlds are interesting and exciting, but really where I need to have information is related to Mars. I want to be able to filter through everything that's been said and find the stuff that the contributors of arguments consider to be specifically relevant to Mars. It's not a perfect filtering because, as you've said, maybe what I'm interested in are saline aquifers in the near subsurface of Mars. So we don't have a pre-selected option for saline aquifers in the subsurface of Mars. We have necessarily, in order to avoid burdening users with too many checkboxes and too many options, tried to limit things a little bit. So the list of predefined arguments generally goes towards surface and subsurface, as applied to specific ocean worlds, to Mars, and to exoplanets. In the case of exoplanets, the distinction is atmosphere and surface. We tried to define those environments in a sense that they might represent targets in a search for life. So I'm sending a mission. This is, generally speaking, the environment to which I will send it. So that provided a first layer, which really is just meant for filtering. I, as the person contributing an argument, want to tell you where I think it's applicable and where I think it's not. Now, in the way that I enter the argument specifically, in the way that I word and articulate the argument, I have complete freedom to invoke any condition, process, locality, or environment that I want. In sitting down to think about what that range of factors might be, you could list them in the hundreds, right? I mean, individually and in combination. And that's intractable to represent in any kind of predefined way. It requires that in order to put it into the system, it becomes a user-defined proposition. So really what we hope to do there is, by training people how to work within the context of this system, by pointing out the necessity for using the argument and its wording as a way to really convey dependence on environment and associated uncertainty, to allow the flexibility at that level of the system to demonstrate exactly that. So the hope was that between those two layers, we allow you the flexibility to say as much as you think is relevant to say. It's imperfect in the sense that the ability to interpret a given feature or a given criterion for a given biosignature, is going to be dependent on hundreds of individual aspects of the environment, and can you really articulate arguments about those hundreds of things? It depends on your stamina, right, for entering content into the system. But the notion is, now you have the flexibility to decide which things are the most important controls, enter those as arguments, and associate them with published bits and pieces of literature. And that's the final thing that I want to say, is that the way the system is set up, so I mentioned that evidence within this system is published literature that supports a given argument that you're making. So, I want to make an argument about the importance of energy flux for an enantiomeric excess. I can only make that argument if I can point to literature that directly supports it. And part of the reason for setting the system up in the way that we have, so being prescriptive about these categories for information, is that it matters as much to understand what you don't know as what you do know. So if we as a community have decided that it matters to understand biological prevalence, and you look at a given biosignature and nothing has been said about it because there's no literature out there to support arguments, that points to a glaring knowledge gap that then you as a researcher or a proposer can seek to fill. And so that's part of the reason for having this standardized structure, is to be able to point that out. So does that answer the question?
It does, yeah, thanks. And I think the time component, it makes more sense when it's viewed from a more applied perspective, as we're sending missions in the modern to go look for these existing biosignatures. So that also kind of helps me frame that component.
Yeah, and you certainly can build in a temporal component as the contributor of an argument. So if, you know, in an example where temporal means, you know, I'm looking at 3 billion-year-old rocks on the surface of Mars, and I'm proposing to use a very ephemeral feature. You as a user can make an argument that degradation will erase that feature in a short order. You know, you can define biosignatures in a time-dependent sense. I am looking for a time-dependent pattern. That's my biosignature. And we do have a category of biosignatures that relate to time dependence activity, be it seasonality, be it, you know, recurring pattern, whatever it is. And the hope, again, is that by allowing user-defined arguments, you have the flexibility to say what needs to be said about that temporal dependence and how it depends on environment. Other questions?
Hi, Tori, I had a question.
Yeah, hey, Tristan.
I really like the distinctness criterion you're adding, but I was a little unclear about one thing. In regards to contamination, is distinctness meant to define the distinction between Earth life and non-Earth life? For example, say we found an enantiomeric excess of amino acids, but that are opposite to those on Earth. So that would indicate, you know, maybe it's not based on Earth, or is it meant to represent the distinction between biotic and abiotic signatures? For example, like a C1 compound is probably not distinct, quote, quote, for determining life versus non-life.
Yeah, it's the first thing that you mentioned, right? So it is specifically meant to say, is the thing that you are seeking also produced by terrestrial life, in which case there's always a potential for contamination and it needs to be mitigated through an implementation strategy? Or are you seeking something that you consider to be a feature of biology, but not of terrestrial biology? And the example that you gave, amino acids, an enantiomeric excess of the opposite-handedness, is one of the examples that we actually used when thinking this through. You know, another might be non-canonical bases that you know, you think you've seen a coding molecule, but one that is not one of our standard you know, base pairing bases. So things like that. And it's part of the challenge that we have in working through where to place this in the system, is that seems like a very kind of specific corner of the world. Okay, there's a very small set of things that you might look for that fit into this category. They're features of biology, but they're distinct from terrestrial life. So in an organizational term, you know, this is something that contributes to the potential for false positive results, and therefore it belongs sort of on the same tier as the other criteria. But it's a very specific thing where you might simply be able to say, you know, not make extensive arguments for or against, but simply, yep, that's part of terrestrial life, or nope, we're looking for something that's not. And maybe that's fine. But yes, it is intended as a distinction for something biological, not represented in terrestrial life, not a distinction between biological and abiotic.
Great, that's awesome.
So I do also want to say, you know, this has been a lot to process. For those of you who are participating in the knowledge base workshop, you'll see a lot of this same ground covered again. So hopefully that will help to reinforce it. The knowledge base itself, as I mentioned, will have a lot of contextual material built into it. So that'll be a chance to cover some of the same ground again. But in the absence of those two, if there are things that you saw and didn't quite get hold of, you can't quite formulate a question right now, I would still love to hear from you. We would still love to hear from you. Please feel free to reach out in the interim. And as Graham mentioned, we are taping this talk. We'll make it available on the resource page of the Enfold website. So if you want to go back, listen again, try to recapture some of what I've said, and then come back to us with questions, we'd love to hear from you. That sounds like it might be it. Any last questions before I let you all go? All right. Let me just say thank you one more time. Again, as I've tried to say repeatedly, we put a difficult task in front of all of you. We asked you to think in very abstract terms that led to feedback that then provided a very concrete basis for something we're hoping to build for the community. And so we really hope this is a useful tool for all of you. And the more you join us, the more you contribute, the more it will become so. So thanks.